Here we've got the trig integral, the square root of sine x times cosine³ x. And to crack this one open, we'll need to do some trig expanding and then a U-sub. So first up, we'll rewrite this as the integral of the square root of sine x times cosine squared x times cosine x dx. And then we'll call on our trig identity, which states that cosine squared x equals 1 minus sine squared x, and we'll rewrite this once more. We'll do the integral of the square root of sine x times 1 minus sine squared x times cosine x dx. And now we're ready to do a U-sub. So what we can do is we can let u equal sine x, the derivative of u, in this case, is cosine x, and then we can plug that into our integrand. So we'll have the integral of the square root of u times 1 minus u squared du. And now we can go ahead and distribute the square root of u, and so what we get is the integral of the square root of u minus u squared times u to the 1/2. When you multiply, you just add the exponents. And so what this is u 4/2 times u 1/2, and the result there is u to the 5/2. And so we can go ahead and write that here, u to the 5/2 du. Now we can rewrite this just so that it's more easy to work with. We'll rewrite it as the integral of u to the 1/2 minus u to the 5/2 du. And now we can go ahead and integrate. So starting off with u to the 1/2, what we'll have is u to the 3/2 over 3/2, and then we flip and multiply, and it'll become 2u over 3. And then we'll subtract u, we'll add 1 to 5/2, and that will become 7/2 over 7/2, and we'll flip and multiply that, and it will become 2/7. And then because this is an indefinite integral with no limits, we must add a constant at the end. Finally, just to complete this, we have to go ahead and plug back in our u value. In this case, we substituted u using sine x, so this problem will be 2 times sine x to the 3/2 over 3 minus 2 times sine x to the 7/2 over 7 plus c. And that is the result of our integral. If you have any questions, or if you've got any other calculus or physics problems you want me to work on, leave them in the comments below. Otherwise, I hope that you found this helpful.